We're all told that our production environments are these super sophisticated, enterprise-grade marvels of engineering. But what if I told you that underneath all that elegant YAML and orchestration lies something a whole lot simpler, and frankly, a whole lot more fragile? Let's peel back the layers and find out what's really holding everything together.
I mean, we are living in what feels like a golden age for DevOps, right? We manage everything declaratively. We just tell our systems what we want. Give me 3 web servers, a database, this specific network setup. And the platform just figures out how to make it all happen. And our single source of truth? Well, it's Git, of course. We define our entire universe in these beautifully structured YAML files, all tucked away safely in version control. We use GitOps to make sure our clusters are constantly checking back with our repos and making it so. It's this perfect vision of order, of control, and predictability. But is that really the whole story? I mean, is our digital empire truly built on such a flawless foundation? Or is there something else, something a little more imperative, holding it all together, just out of sight? So first, let's just take a moment to appreciate this polished facade, this declarative utopia. It is an incredible achievement, no doubt about it. We've built systems that let us manage just immense complexity with a level of abstraction that, was pretty much unimaginable just a decade ago. And this quote, it just nails the core promise, doesn't it? Kubernetes is the perfect example. It's built from the ground up around this one idea. You declare what you want, this container, this many replicas, this much memory, and the system's job is to make it a reality. This is the dream we've all been sold. And yeah, this dream is supported by some really powerful pillars. We've got infrastructure as code tools like Terraform that let us define entire cloud environments in files. We have GitOps, ensuring our clusters never drift from what's in the repo. And of course, our CI/CD pipelines automate the whole thing, from the moment you commit code to the moment it's deployed. It's supposed to be this robust, manageable, automated world. So, if everything is so perfect, so declarative and automated, what are we even talking about today? What's the secret ingredient that's working in the shadows, connecting all the dots and filling in the gaps? Well, the answer is surprisingly, maybe even alarmingly simple. It all comes down to just 3. Yep, 3 humble shell scripts, lurking in the dark corners of our pipelines and our cron jobs, doing the absolutely critical, imperative work that our fancy declarative systems either can't or won't handle. So let's unmask these 3 scripts. Now, they're not literal scripts, of course. They're really metaphors for the types of brittle imperative logic that we all rely on every single day just to keep our supposedly declarative world spinning. First up is what I call the deployment glue. This is that little script that lives right inside your CI/CD pipeline. Its whole job is to bridge the gap between building an artifact, say a Docker image, and then declaring that new artifact in your configuration. It's the one crucial imperative step in what's supposed to be a purely declarative process. And here is a perfect real-world example. Your CI pipeline builds a new image and slaps a unique commit hash on it as a tag. Great. But how does your Kubernetes YAML file find out about this brand new tag? The answer, more often than not, is a simple, powerful command like sed. It's a one-line shell command that just reaches in, directly manipulates that YAML file, updates the image tag, and commits it back to Git. That's it. That's your essential imperative glue. Okay, next we have the operational task. This is the script that runs on a schedule. It's that trusty cron job humming away on some forgotten EC2 instance in the corner. Its job is to handle all the routine, operational work that doesn't really fit neatly into your main application or your infrastructure code. I mean, think about this super common scenario. Management wants a daily report of all active AWS resources so they can keep an eye on costs. You're not going to build a whole new microservice for that, are you? No way. You're going to write a shell script. It'll use the AWS CLI to query for instances and buckets and users, format the output into a nice tidy file, and maybe even email it off. It's a classic, totally indispensable operational task, and it's powered by Bash. And finally, we have the system manager. Now, this is the most powerful and honestly often the most frightening of the 3. This is the script that's responsible for managing the health, the configuration, and the status of your entire fleet of machines, often at a massive scale. Just try to imagine managing 10,000 virtual machines. You need a way to check for weird behavior, like, high memory usage or suspicious processes running. So, what do?
You write a shell script. It loops through every single machine, runs a few diagnostic commands, and sends an alert if it finds anything. This is large-scale systems administration at its most raw and its most effective. So we've revealed the 3 scripts, but that begs a pretty big question. In a world full of Go and Python and all these advanced infrastructure as code tools, why do we keep coming back to the humble shell script? What is its enduring allure? Well, when you look at it this way, the trade-offs are crystal clear. Shell scripting is the absolute, undisputed champion of simple glue code. And why? 0 dependencies. It is already on every single Linux system you will ever touch. Now, compare that to Python or Go, where you suddenly have to start managing versions and libraries and virtual environments. For a quick 10-line task, that is way too much ceremony. And this right here, this quote hits on probably the most powerful feature of the shell, its incredible longevity. Core utilities like grep, sed, awk, they're bedrock. They just work, and they have for decades. Now compare that to a Python script from 5 years ago that depends on some outdated library that won't install anymore, or a Terraform module whose provider just introduced a bunch of breaking changes. The stability of the shell is a massive and I think often overlooked advantage. But, and this is a big but, this convenience comes at a cost. This desperate convenience of Bash creates what is a really fragile foundation. When these unmanaged, often brittle pieces of imperative code are propping up our beautiful declarative systems, we're introducing some serious systemic risk and instability that's just being masked by these clever little workarounds. Configuration drift is the classic example of this risk. So maybe it happens when a teammate makes a quick manual fix in the AWS console, but it can also be caused by one of our scripts making a direct AWS S3 API call. Either way, you now have an out-of-band imperative change. Reality has drifted away from your declarative source of truth, and that's just asking for future failures and a whole lot of confusion. What's even worse, though, is when these scripts fail without telling anybody. See, by default, a shell script will just happily keep on executing even after a command inside it fails. So if your deployment glue script fails to update the image tag, but the rest of the pipeline succeeds, you might think you just deployed a new version when actually you haven't. These silent failures create a really dangerous false sense of security. The good news is we can do better. We can absolutely tame these scripts. First, add set A to the top of every single script you write. It's a simple little command that makes sure the script will exit immediately on any error. No more silent failures. Parameterize them, just like that sed script we saw so they can be reused. And maybe most importantly, put them in version control. Treat them with the same respect you give your application code. So look, the crucial point here is this. Shell scripting itself is not the enemy. It is a powerful and, I'd argue, necessary tool. The real problem is when these scripts become an unseen, unmanaged, and brittle foundation holding everything up. When we write them with intention, when we test them, and when we manage them as critical pieces of our infrastructure, they can actually be a strength, not a weakness. Which leaves us with one final big question. As our systems get even more complex and our declarative tools get even more powerful, will they ever truly close all the gaps? Or are we destined to always be propped up by a few critical, imperative lines of Bash? It's definitely something to think about.